It's very important when teaching adding to teach the value of the numbers and to have students think about what they are actually doing with real amounts, not just with digits. So when we teach adding, something that we can do that's a very positive step is to have them think about place value and to think about the value of the number in general and even consider estimating before they do the adding. So we're going to look at adding in a different way. We're going to look at adding using place value. So for example, on the left, you see the problem 35 plus 53. Of course, the very first thing we want to do when we're teaching something that's new to students is to use real objects. So base 10 blocks, all kinds of manipulatives can be used for this. In the picture, you'll see that we have images of base 10 blocks, and you see this a lot on worksheets, but it's much more beneficial to have students actually use the real blocks. So as they look at the number 35, they're going to see that there are 3 10s and that there are 5 1s. And I apologize that the ones are so large here and not in proportion, but it will give you the idea. Same thing with 53. When they look at the number 53, they see that the 5 represents the 5 10s and the 3 represents the 1s. Now why this is so important is because they can't just think about numbers. 5 of something and 3 of something. They can visualize that. But what they're seeing is 5 different things from the 3 objects. It's almost like we have 5 apples and 3 oranges. They're not the same. And they need to see that. They need to see that the 5 in 53 represents rods of 10, groups of 10. It's very important that they can visualize that. So when we add, if we were using these objects, we would whoosh together the like things, because when you add, you can only add like things. If we're adding apples and apples, we get apples. If we're adding oranges and oranges, we get oranges. If we're adding 10s and 10s, we get 10s. So it's very important to have them actually physically do this. And of course, the nice thing is that it doesn't matter where they start. They can start with the 10s, they can start with the 1s. So if we start with the 10s and we take these 3 10s here and we group them together with these 5 10s here, we move them together, we get 1, 2, 3, 4, 5, 6, 7, 8 10s. So when they write that underneath their problem, they would write 8 10s, which of course is the same as 80. Then they would go to their 1s, and if they whoosh these together, we would have 5 1s here and 3 1s here, and again, that would be 8. So we have 8 10s and 8 1s, and our answer then is 88. So even though the numbers are both 8s, they represent very different things. This 8 represents 8 of these, this 8 represents 8 of these, and students really need to understand that. If we look at the other problem that we have, we will see that we have 10s, and again we have 1s. So the 62, 1, 2, 3, 4, 5, 6, we have 6 groups of 10, and we have 2 1s, 62. In the 38, we have 3 groups of 10, and we have 8 1s. Now if we add like things again, of course, we're going to look at all of these 10s and see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 10s. So that would be written like this, 9 10s or 90. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 1s. Now, what's important for students to understand is that when we write that 10 1s, we have another group of 10 here, and that's why we write it this way. We have one group of 10, and we have 0 1s. So if we add those together, we see that we now have no 1s, and we have 10 groups of 10. The 9 groups of 10 plus the 1 group of 10 makes 10 groups of 10. So altogether now we have 100. So again, to be able to visualize these groups of 10s and this group of 1s, which makes another 10, and the total being 10 10s, 10 10s, that is the same as 1 100. So it's very, very important that students can see this, that they understand it, they can visualize it. Now, once we get past the real objects and we want students to just do this mathematically, we want to think about estimating so that their answers are reasonable, so they know that. We also want to think about having them be able to do this any way that makes sense that uses the value of the number. So we can teach this exactly the same way we did it, only without the manipulatives. So if we look at this first problem, we see that we have 3 tens and we have 5 tens. That's going to be 8 tens. So students right off the bat can estimate and say, okay, my answer needs to be somewhere around 80. I'm adding more ones, so it's going to be more than 80. And if we then go to the actual work of figuring it out, 3 tens and 5 tens is 8 tens. 5 ones and 3 ones is 8 ones. And if we add those together, we get 88. If we go to the next problem and we see we have 6 tens and 3 tens, that's going to be 9 tens. That's 90. So students will know that our answer is going to be around 90. We have a lot of ones to add here, so it's going to be more than 90. We want them to know that so that they can check their answer to make sure it's reasonable. 6 tens and 3 tens is 9 tens. 2 ones and 8 ones is 10 ones. So we want them to think 10 ones, that's another group of 10 without any ones. So that's how we write that. And when we add that together, we don't have any ones now that aren't in groups of 10. And we have 10 groups of 10. 10 groups of 10 is the same as 100. And just that thinking process, 10 groups of 10 is 100, is very, very valuable to students. In this problem, we have 3 100s and 5 100s, so our answer is going to be at least 800, but we have a lot more here to add, so probably students are thinking our answer is going to be more than 800. 500 and 300 is 800. 7 tens and 4 tens is 11 tens. Sort of like 7 apples and 4 apples is 11 apples. 7 tens and 4 tens is 11 tens. 8 ones and 3 ones is 11 ones. Now we want students to be able to think right off the bat that 11 ones would be a group of 10, that would be this one right here, and then one leftover one, which is why it's written that way. So the group of 10 goes in the row with the tens. So if they add this all together, then we have 1 1, 2 tens, and 9 100s. So we have 921. The estimating part of this is important because when they get their answer, they can go back and say, okay, does that make sense? Is it reasonable? Now, once we get past that conceptual part, what we've been doing so far is very conceptual, working with real objects, even working with the numbers, but talking about the value, the place value. And some students will want to do their adding that way forever. And truthfully, if they understand it better that way, if it makes sense to them that way, if they want to start from left to right, if they want to think about starting with hundreds or tens, I don't see any reason not to allow students to do that. Most schools, however, and most teachers would like to get kids to the point where they can do this procedurally because it's quicker, it's faster. We don't have all those rows of numbers to add. We want to make sure, however, that students don't move to that point before they're ready, because if they're not ready, it's not going to make any sense to them. So what kind of thinking do we want to hear from them when we get to the point where we do this in a more traditional way? How do we add traditionally? What we want students to be thinking still is the value of the number. So for this first problem, what we would want students to say is 5 ones and 3 ones is 8 ones. 3 tens and 5 tens is 8 tens. And our answer is 88. And as they're saying that, we want them to be able to visualize what a 1 looks like and what a 10 looks like from their work with the place value blocks. For this problem, we want them to think that 2 ones and 8 ones is 10 ones. Now, typically we would have students write the 0 first, but really it makes a lot more sense to many students if we actually put the 1 up here, because 2 ones and 8 ones is 10 ones. We have another group of 10, and that's what this represents. Sometimes we say we're carrying the 1, and when students are positive of what they're doing and we're sure they understand it, I think it's fine to use that word. But in the beginning, we want them to be able to say we're putting that 1 up there because it's a 10, and so we have to put it with the other 10s. We put the 10 up there, and we don't have any leftover ones, so we put the 0 there. Now we go and add the 10s. We have 6 and 1, which is 7, and 3 more, which is 10 tens. 10 tens. We want them to visualize those rods, and we want them to understand that 10 tens is the same thing as 1 100, just like we did when we used the place value blocks. Now, when we move to the hundreds place, we still want that same language. We want students to be thinking 8 ones and 3 ones is 11 ones. So we put the 1 up here because 11 ones is made out of 1 10 and 1 1. So the 1 10 goes with the tens, and the 1 1 stays with the ones. Now we can add the tens. 1 and 7 and 4 is 12 tens. We want students to think of 12 tens as one group of 100 and 2 tens. So the one group of 100 goes with the hundreds because we add like things. The 2 tens goes with the tens. Then we move to the hundreds place, and we add 1, 3, and 5, and we get 9 hundreds. We want students to understand that that 9 represents hundreds. Our answer is 921. So we have 9 hundreds, 2 tens, and 1 1. It's very important when we think about adding that we start with real objects so students see that a 10 looks different from a 1, that it's a group of those ones, that 100 looks different from a 10, that it's a group of tens or a group of 100 ones. It's really important that they be able to move back and forth and see the relationship between the ones, tens, and hundreds. Once we've worked with real objects, then we can move to the place value kind of adding, where they're saying 3 tens and 5 tens is 8 tens, and they're just writing 8 tens. They're thinking about the value. Once they can do that, then we can go to the steps that we have done on this last slide, which are just the procedure. But even then, we want students to always be able to think about what they are doing, the value of each number. Every once in a while, we should back up and ask students to do this kind of adding aloud and to use the language. So we hear them say 6 tens and 3 tens is 9 tens. And they're not just thinking about these as digits. It's very important for future work as we build.